Okay, 6th grade, our objective today is to compare and order integers. So we're finally getting into some concepts and terms that are new to you. We are going to talk about today, well, what is an integer? How do you order them? What is absolute value? And if there's time, we're going to look at the types of numbers chart, which I really like. I think it's a nice way for you to know, well, how do we name certain numbers? Okay, so we're going to compare and order integers today, and we'll see how it goes. And if we get to that types of numbers chart today, good. If not, we will wait until tomorrow. Just a reminder that you will not have a quiz in this chapter. The chapter 1 test will be in about a week and a half. Okay, so you will not have a quiz on this chapter since it's a review, but you will have a test. I'll let you know when that's going to be. The Blackboard email. I didn't get a chance yesterday to work on that because I want to make sure that you are all up to date with the email in there. So I apologize. I hopefully will get to that today or tomorrow. So as soon as I do, I will explain to you how to use the email from Blackboard in case you ever have to email me. In the meantime, does your email work from school? Has anyone tried like your personal email, Doug? Does it work from school? Okay. You're more than welcome to email me from Gmail if you guys have it or any other email. And you know on the syllabus my email's on there. I think you guys know that, right? My email is on the syllabus. Adam?
I'm pretty sure everything except
Okay. And that's why I want to show you how to use the Blackboard email because I'm pretty sure that you're correct about that. Mary?
well, our school for internet things, we were not allowed to put our name or email address.
Okay. Okay, you're not even allowed to email me through Blackboard from school? Okay, I think that would be okay because all you would do is click on email teacher and it would just email me directly. So I think that would be okay. And you can ask one of your teachers or whoever's in charge of that to see if that's okay. And if not, no big deal. You won't need to email me very often. It'll just be when you're absent or if you guys have questions, which you can do from home. Okay, so I just wanted to give you guys those updates. Any other questions or comments on anything? Okay, also don't forget Kleenexes if you want to bring them in by tomorrow, that's fine for a couple extra credit points. Book covers, I think we just need a couple more book covers. Try to do that in the next couple days. Alrighty, warm up. Let's start with number 1. Alyssa, greater than or less than? Good, less than. Charles, number 2. Good. Number 3, Justin. Good. Number 4, Adam. Good. Ordering numbers from least to greatest. Jeremy, what did you get for number 5?
4.72.
Great job. Number 6, I'm just going to have you guys give us the answer. Emma H., number 6. Good. Mary, number 7. Close. Well, I shouldn't say close. You're good job. You have the right number. You just needed that decimal point in there, so I guess that makes a big difference, I guess. Number 8, Annalise. Okay, I will go over that in a minute. I just want to go over the rest of the answers. Number 8, Doug. Good, 336.5. Matt, number 9. Yes, great job. Number 10, Zach. Or did you not get to it? Okay. Anyone get to 10, Alyssa? Good job. Very good. Okay, so let's go back to the first page. Mary? Go ahead.
Number 8, I got 293.5. Number 10, I got 141.
Okay, let me start with Annalise's number 7, and then I'll go to yours.
I have questions on 7 and 8.
Okay. Okay, so number 8 will take care of both your questions then. Okay, so let me start with 7. Let me extend this page here. Okay, so, okay, number 7, Annalise, the very first thing you need to do is take care of what is inside parentheses. So these innermost parentheses, take care of that. Rewrite the 6, rewrite your brackets. We have 14 minus 0.9 or 9/10. So I'm just going to pause there. Did you have that? Okay, and then just subtract what's inside the brackets. So we have 13.1. 6 times 13.1 is 78.6. Okay. Make sure you do what's inside the innermost grouping symbols first and then work your way out. Okay. 13.1. Okay, so then you just subtracted wrong by accident, which happens. So you know your order of operations, just be careful with your math skills there, like the small skills with adding and subtracting. That's easy to fix. Adam? Okay, hold on a second. Anyone else on number 7? Justin? Go ahead. Yeah, true. Maybe you did put 1.4 by accident. Thank you, Justin. That's probably. And that happens. Okay, Adam, go ahead. Yes. Because they want you to take care of this first, and I don't know, I guess just to group the problem together. The book does that sometimes. That's, I don't know, maybe because they felt like it. I'm not quite sure. That's a great question. Okay, number 8. Raise your hand if you need me to go over number 8 so I know who I am talking to. Okay. All right, number 8. Mary, what's the very first thing that you thought to do on number 8? Okay, good. So I'm going to rewrite this. What did you get after you subtracted? I'll start with you, Mary. Good. Emma M., what is the next thing you did? Good. So what is 1.5 cubed? Good. Okay. Annalise, what's the next thing we should do? Okay. That's where you made your mistake. So at this point, you want to multiply, divide from left to right. So we have to take care of this multiplication first. That, you know, we know that it's GEMDAS, we know that it's PEMDAS, but when you see a problem, sometimes you just forget because it looks like, oh, we should subtract first. So it does look like that. Be careful though. Make sure, I would even write GEMDAS on your paper. Multiply, divide from left to right. Mary? Yeah. And that just happens. I think that Annalise did that for the previous problem where she just wrote the number wrong. So that's going to happen. Of course, that's going to mess up our answers, your answer. So, Justin. Okay, no. Remember, always multiply, divide first, and then add, subtract from left to right. That makes sense? Okay, Emma M. Go ahead. Okay, let me finish this real quick. Okay, so after you then subtract 303 minus 13.5, you get 289.5 plus 47. Add them. That's how we get 336.5. So before I go to 9 and 10, any other questions on number 8? If you got it wrong, you probably should fix it. That way you don't do something like that again. If you didn't do the problem, make sure you know how to do it and make sure you write the answer down. Okay? I'm not just doing this to fill time. I'm doing this to make sure you guys know what you're doing. Okay, number 9. Emma, did you say, or 10? Did anyone need me to go over 9? Okay, number 10. Okay, so number 10, let me plug in first. So B is 4. So we have 5 times 4 plus A is 8. So did you plug everything in correctly? Oh. Okay, so that's why then. So at this point, does anyone need me to keep going, Mary? Okay. Okay. That happens. So there's the rest of the work if anyone needs it. Okay, thumbs up, thumbs middle, thumbs down on the warm-up. We're not completely done with order of operations. I want to look at your papers from last night. We'll come back to it. Okay, thank you. All right, we're good? Okay, moving on to our notes, which are right underneath that. Okay, there are a couple definitions that we need to talk about. The first one is an integer. So it's actually nice that this is now. We did talk about this a little bit yesterday, and this is when I was explaining that an integer is a nice number. Okay, you guys should be writing this. It's underneath define. An integer is a nice number. So by definition from your book, it says integers are the numbers from negative infinity all the way up through positive infinity. Integers are all negative numbers, all positive numbers, and 0. So that little squiggly upside down 8 That means infinity. Have you guys seen that before? Okay, good. So it goes from negative infinity all the way to positive infinity. It includes all the negatives, 0, and all the positives. And again, when I say a nice number, I mean no decimals, no fractions, no mixed numbers. So that's an integer. You will hear these types of number words a lot throughout this book. I think some of them you may have heard of. Sean? I'm going to show you that in a second. And no, it does not. Negatives are not whole. And same with natural numbers. Natural numbers are not whole numbers. Or sorry, natural numbers are not negative numbers. I'm getting to it. Annalise? Correct. Integers cannot be decimals, cannot be fractions, cannot be mixed numbers. So I will always say an integer is nice. Okay, it's nice and pretty. Charles? Yes, you could think of it that way. That's a great way to think of it. Yes, plus negatives. So like a first grade number plus, when did you guys learn negatives? In 5th grade? Around there? Okay. Okay, well, I'm going to teach you now this year. We're going to learn them probably tomorrow. Mary? Okay, so it was just like common knowledge, like you guys just know them. Justin? Good. Good job. We're going to have that discussion tomorrow. You guys are pretty good at knowing what the next lesson is. Very good. Okay, second definition, negative integers. Here we go. Integers that are less than 0. So I'm going to teach you what a negative integer is. Integers that are less than 0. When in life do you hear or see negative numbers? So when in life, not just math. Alyssa, when in life? Awesome. On a thermometer. So if we go to Alaska, when it's really cold, it might be like negative 25 degrees. That's very cold. So on a thermometer, great example. Donatus. Oh, you're in big trouble. Yeah, so if you're in debt with your money, not a good idea. Maybe you can't make your mortgage payment. You're in big trouble, right? So great example. You're in negatives with money. You owe someone a lot of money, or many people, or companies, banks, a lot of money. I like that example. Good, in math class, what else in life do you see negatives? Annalise. Yep. So betting, card games, betting. Emma M. Yep. Anything with a game when your points get negative. Justin? Yeah. So you're like it's $1 off of that price. Some stores will mark their sale prices like that. You're exactly right. Doug? Stock market. Yeah, we probably shouldn't talk about that. Like in 2008 when it went way down. It's getting there. But yes, stock market goes down. Even every day, individual stocks, mutual funds, you'll see whether they're up or down for the day. So you'll see negatives there all the time. Do you? Yeah, it's interesting. Adam. Oh. Ah, right. Neat. So that's a great learning tool. I like that. Okay, so next to where it says negative integers, I want you to make a number line and make 4 little tick marks next to it. So where it says negative integers, make a number line, make 4 little tick marks next to it, or on it. Okay, I want you to put 0 on the 3rd tick mark. Put 0 on the 3rd tick mark. So what goes to the right of 0? This might sound like a silly question. What goes to the right of 0? Matt. Good. Charles, what goes to the left of 0? Good. Briar, what goes to the left of -1? Good. So here's my point of this, and I didn't do this last year, but don't forget on a number line, to the left the numbers get smaller. To the right the numbers get bigger. I know it might sound really silly, but it happens. There are people that make that mistake. To the left it gets smaller, to the right it gets bigger. A number line, as you will learn in geometry, keeps going on in both directions forever. Emma M. Mm-hmm. we're going to kind of do some of that today. Did they have the number line going in the correct direction, like the negative? Okay. Doug. Yeah. They want you to think. Okay, positive integers. So the second definition or third definition on that page, integers that are greater than 0. So we don't really need to talk about this. You know what a positive number is. There are many, many things in life that we use positive integers for. Okay? And on your number line, positive integers go to the right. So positive integers go to the right. Okay, when you're ready, go ahead and flip over your notes. What'd you say? Yeah, I know, number lines. Alrighty, so we're going to use the number line to order the numbers from least to greatest. Who can tell us from that list what is the smallest number? Mary, smallest number.
Negative.
Good. Write -9 on the number line like I am, and please cross it off as you're going so that on a test or quiz, you know what number you already used. So I'm trying to teach you skills as we're learning this today. Okay, Charles, what's the next smallest number? Great job, -8. Okay, the next smallest number, Sean? Good, -6. Zach, the next smallest number? Good, -2. Alex, the next smallest number? Good, 0, 3, 7. There we go. We have our numbers in order from least to greatest. You will definitely see this on your Chapter 1 test. Please pay close attention to how they want you to order it, whether it's just to order them or to put them on a number line. Make sure your negatives are always going to the left, positives are always going to the right on a number line. Okay? Alrighty, before I flip the screen, we're going to talk about something now called absolute value, because we can take absolute value of an integer. Does anyone know or remember anything about absolute value? Doug? Oh, I see what you're saying. Okay, yes, you are correct. Mary? Okay, you're close. Charles? Uh-huh. Okay. 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 Right, right. So did she explain to you what that means? Yes, I like that she did that. That was pretty tricky of her. So yes, absolute value, by definition, is the distance from 0. Okay, absolute value, by definition, is the distance that a number is from 0. So I like that example. If you're playing a card game and, Charles' mom said, oh, well, I'm going to change it to absolute value. If she had -48 and the goal was to get to 50, that really means that she has +48 and she could be winning the game. Absolute value is always positive. The distance something is from 0. So if we had a number line and 1, 2, 3, 4, 5, and I had a -5 on there, how far is -5 from 0? M. Good, 5 units. So you could also say the absolute value of -5 is 5. So you could start talking in absolute value code. I might say, I'm going to run the absolute value of -5 miles today after school. So you can start talking in absolute value code, because that really means I'm going to run 5 miles. Doug?
Every morning I run for especially in the summer, I run for 3 hours, but every morning I run for 150, and at night I run around the field.
Good, good. So absolute value is always distance from 0. It is always positive, okay? All right, so let's find the absolute value. On letter A, put the absolute value bar around 7. The absolute value of 7, Donatus, is what? Great job. So don't worry about the number line, just put equals 7. Emma H, what is the absolute value of -5? Good, +5. So that's pretty easy, right? Absolute value is the distance from 0. Something kind of cool that I want to show you is, you don't need to write this down. If this is a coordinate plane, do you want to see what the absolute value graph looks like? So if we were to graph this on our calculator, which we'll do in Chapter 8, this is what the absolute value graph looks like. It looks like a V, okay? This is something that when we get to Chapter 8, we will talk about. That is a function. But that is what the absolute value graph looks like. That's the positive version. The negative version looks like this. Jeremy.
So, in this case, if it's negative number, just positive, and it's a positive number, it's
Yep, exactly. Because absolute value is the distance from 0. So distance is always going to be positive. Always. Okay, I want you to add a letter C and a letter D wherever you have room underneath those number lines. So add a letter C and a letter D. I made them a little bit harder. Well, maybe not letter D. If you want, yeah. Okay, so letter C, we have the negative absolute value of -3. What do you guys think the answer to that is? This is a challenge question. What do you think the answer to that is? Justin? Nope. Mary? Why? Good job. So the absolute value of -3 is 3, and then we need to drop down the negative symbol. Annalise? Yeah, add letter C and D underneath the number line, wherever you have room. Sometimes I throw problems in to make it a little bit harder. Okay, what about letter D? Absolute value of -100, Briar. Good. Absolute value is always positive. So -100 is 100 units from 0. Don't forget that definition. Any questions on that? Annalise? Yep. So this is an absolute. This is the absolute value bar. So yes. Yep. What'd you say? Oh. Okay. That's all right. Was it a student or teacher? Okay. Adam. Good. Oh, I'm getting to it. Hold on. Wow, you guys are asking great questions. It's always like the next thing I'm going to do. We're getting to it. I'm going to tell you. Okay, hold on. Any other questions on this? Okay, next definition, and we're getting to what irrational is. Okay, opposites. You probably already know this, but this is a term that's extremely important for this book. Two numbers that have the same absolute value but different signs. Two numbers that have the same absolute value but different signs. So if two numbers have the same absolute value but different signs, -2 and 2 are great examples. They have the same absolute value, which is both going to be 2, but one of them is -2, one of them is +2. So can you give me another example of opposites? What's another example of opposites? Annalise? Yep. Good. -50 and +50. Any number, one's positive, one's negative. Mary? Good. -pi and pi. Perfect. Okay, so let's find the opposite of the examples right below the definition. So Alex, what is the opposite of 6? -6. Good. And you can say either minus or negative. Jeremy, what is the opposite of -5? Oh, sorry, -15. Good. Opposite is positive 15. Alyssa, what is the opposite of negative negative 4? I'm trying to trick you. Nope. The opposite of negative negative 4. Good. Do you know why? So 2 negatives back to back really means what? Did you guys learn this last year? Maybe you didn't learn this. That's fine. 2 negatives back to back. I always use the example of 2 markers or 2 pens. 2 negatives back to back, they collide and they make a positive. So 2 negatives back to back, they run into each other, they collide, they make a positive. So we'll talk about this in 2 days too. But 2 negatives back to back always makes a plus. They're colliding. So together they form a positive. Negative negative 4 is really positive 4. So the opposite of positive 4 is negative 4. There's a question on your test like that. Adam. You can do whatever you want. Yes. You can use as many negatives as you want. Annalise. Yep, the answer, oh no, sorry. The answer for the opposite is negative 4. I put this up here because the problem in letter C, negative negative 4, is really positive 4. So I just changed that because it's really a positive 4, not a negative 4. Alex. There could be, but we won't really see that in this class, but there could be. Okay, anyone else have questions on that? Okay, the closing. I want you guys to try. Be careful, these are hard. A, B, C, D. So this is having you put everything together for the most part that we've learned so far. You need to evaluate the expressions when y equals negative 5. So go ahead and try A, B, C, D. And then when you're done, just put your pencil down. Negative. Do that one again. Yep. When you put the negative in, what's negative negative 5? Yeah. Good job. Awesome job. Very good. I'll be right over, Annalise. So write down 17 minus and then do absolute value of 5. Does that help you? Yeah. Yep. You're welcome. You good? Okay, try that one again. Try that. Is that a 15? Try these 2 again. Oh, and this one. Yes, quickly though. Oh, I just realized that one's off a little bit. Try that one again and that one again. Try 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 that again. Try that one again and that one. Nope. If I didn't say anything, you're good. Let's try those 2 again and be careful on that. Yeah. We're going to do that tomorrow. Is that what the problem is? Oh, you just did it wrong. Plug back in. It's absolute value of negative 5 minus 1. Because I didn't, those rules, you're welcome. We're going to do tomorrow. Good. Very good. Okay. Matt, what'd you get for letter A? Good. Positive 5. Letter B, Alex. Good. Now let me just go over this one. 17 minus the absolute value of negative 5. A lot of you guys put 22 as your answer. Follow order of operations. This absolute value symbol is considered a grouping symbol. So rewrite 17 minus the absolute value of negative 5 is positive 5. So that's why some of you got 22, because you changed that to a plus. Take care of absolute value first and then subtract. Is everyone clear on that? Jeremy? No, because the absolute value of -5 is +5. Jeremy, does that make sense? Anytime you take absolute value, the definition is it's the distance from 0. So it always becomes positive. All I did was drop down this minus sign that was already sitting there. Okay? Alex, you okay? Okay. All right, letter C. Justin, good. 5. Letter D. Annalise, go ahead. Yep, so ready? There's a negative in front of the absolute value symbol, so I'm going to rewrite that. -5 goes inside the absolute value symbol. Okay, so now here's the tricky part. This negative sign in front needs to be dropped down. The absolute value of -5 is +5. And then rewrite the +10. Now I'm going to teach you guys tomorrow how to add if you have opposite signs. So if you don't know your negatives very well with integer rules, -5 plus 10 is 5. So yeah, so anytime you're adding and there's opposite signs, you subtract, take the sign of the larger number, which I'll teach you tomorrow. Emma M just said it. Mary? Yes, you may. Good job. Letter D, we have the absolute value of -5 minus 1. The absolute value of -5 is +5. Drop down the -1. That's how we get 4. So give me a thumbs up, thumbs middle, thumbs down on those types of problems, which we're going to do more. I have a challenging warm-up of those that you're going to try tomorrow. Okay, thank you. Okay, I want to spend a couple minutes just starting to talk about types of numbers. So if you could flip your notes to the next page. Okay, these are very, very basic definitions. So I want you to write down for natural numbers. A natural number is a positive number. Don't write any words. I just want you to write down 1, 2, 3, 4, comma, dot, 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 infinity. What do all those dots mean? Did I just get bored this morning at 6:30 and decide to start drawing dots? Adam? Yeah, it goes on forever. Okay, so no, I didn't just sit there and randomly draw dots. It just goes on forever. A natural number always starts with 1. It goes on forever. Okay, what do you think a whole number starts with? Charles?
0.
Good. Charles, what else do you know about a whole number? It starts with 0. What else do you know about it?
Not
Good. So it goes from 0, 1, 2, 3, dot, 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 all the way up to infinity. Natural numbers, whole numbers, and integers never include decimals, never include fractions. Okay? Never. Annalise? It's just by definition they don't. There's some things in math, there's not any other reason besides by definition, it's just what it is. Okay? The integer is the one that does include the negatives, but all 3 of these are always the nice numbers. There's never decimals, there's never fractions. So we already wrote down the integer, so we could just write this down again. An integer goes from -infinity all the way to +infinity. That means it includes all the negatives, all the positives, and 0. So a natural number starts with 1. A whole number starts with 0. Integers include all the negatives, all the positives. Questions on those 3 definitions? No? Okay. A rational number. This one is a little bit tricky. A rational number. So if you just think of the word rational in general, if you're rational, you're making a good decision. If you're being rational, you're being realistic. Okay? It kind of works the same way with numbers. It's any number that can be expressed as the quotient, A over B, of 2 integers with denominator b not equal to 0. So I'll say that again, and then I'm going to simplify that definition. A rational number is any number that can be expressed as the quotient AB of two integers with the denominator not equal to 0. So the denominator cannot be 0 regardless of what we're talking about, because that would make it an undefined function. We will discuss that in chapter 8. So just remember that denominator cannot be 0. A rational number is a perfect square. Has anyone heard of a perfect square? What's an example of a perfect square? Is it honest, Dina? Okay, yes, but perfect square meaning something like this. But you're correct. Good. Why? Good job. A perfect square, and we're going to get to this too. This is chapter 9. And a perfect square is anything you take the square root of and you get a nice number. The square root of 9 is 3. The square root of 16 is 4. The square root of 100 is 10. What's the square root of 121? 11. Good. What's the square root of 169? Come on, all you math brains. What's the square root of 169? Emma H. Yep, 13. Okay, raise your hand. No yelling out answers. What's the square root of 196? Shh, don't say it. Hey, Adam, no cheating. Put your calculator down. What's the square root of 196? Hey, put that calculator down. Come on, down. I can see. I'm not 80 years old. Put it down. What's the square root of 196? Briar. Nope. Square root of 196. Come on. Sean. Good, 14. Okay, one more. What's the square root of 225? Okay, this one's easy. Justin? Good, 15. All right, so perfect squares. Those are rational. A fraction. A decimal. Mixed number. Also improper fraction. And a repeating decimal. And I'm running out of room there, so I'm going to abbreviate. Repeating decimal. What I mean by repeating decimal, Doug, do you know what I mean by that? Yeah. Okay, what goes above the 3? Or the 3, 6 if you want to do that. Do you know what notation we use to mean it's repeating? Annalise? Yep, I always call it a hat. We're going to put a hat on it. It goes on forever and ever and ever and ever. So 3, 6 is repeating, it goes on forever. So that's a lot of stuff. Those are all examples of rational numbers. Okay, I would love to talk about what is irrational, but we don't have time. So we're gonna pause there on that. I want you to think for tomorrow of what in life, what does irrational mean? And we'll talk about that tomorrow before we start this. Okay, your homework. So open up your homework packet. 2, you're always gonna have homework from me, sorry. Hey, you're in accelerated math. You should expect it. No slacking. Sean. Sometimes you will. I mean, if you guys figure, we do about 1 section a day. Today we did 1.5 lessons. There's some days that we're moving. So yeah, for the most part, you're gonna have homework. But you have time in school in your math class, so no complaining. Mary. Yes, so open up your homework packet to 1.4. Numbers 1 through 31. That means the whole thing. So instead of putting all, I will put the numbers. Front and back. It's not difficult. It talks about opposites, absolute value, evaluating, and simplifying expressions. Okay, Doug, next time ask me to get up. Okay, don't just get up. So 1 through 31. Okay, back and front of 1.4. Is everyone good? Okay, when you're ready. Oh yeah, the graded homework assignment, thank you Jeremy, that I passed back. If you have to either finish problems or make corrections, feel free to take your book home if you need to, or use the online book. I need that by Tuesday at the latest next week, okay, in case you guys are busy tonight. Yes? This homework? Practice 1.4. Can you not see in that seat? Okay, numbers 1 through 31. Anyone else need anything? Doug? Yes, you may. Just make sure you ask next time. Okay, when you guys are ready, you can go ahead and get packed up. Great job today.